Hi everyone, please say something in chat, whoever is live right now. And is my voice coming good? And what about the video? I was stuck at C. Is it hard or medium? Let me see the C problem. Yeah, I think this is somewhere between medium and easy. It's not a difficult one at least. Hi. Yeah, hi. Okay, so let's wait for a few more people and then we can start the stream. By the way, how many problems did you guys solve? And let me also. By the way, how many problems did you guys solve? Okay, I think the voice is coming good. Two. Okay, nice. Okay, nice. Only solved A, almost at C. Okay. I think today's contest was on the easier side. All the problems A, B, C, D were easy. D was a bit tricky one, but not difficult. At least it didn't require a lot of extra knowledge. Even if you have done things like Striver A to Z sheet, it would be doable. While saying the answers, please say the brute, better, and optimal too. If I do in that way, then the PCD will go really long. And generally during contest, you won't start from the brute, better, optimal. You will just start from the obvious approaches, the obvious observations, and then you will try to move on to the harder problem. Like, let me think of an example. Yeah, let's say that there is a problem related to subarrays. Then you're most likely gonna think of an easier problem. That, let's say, if you had been given a complete array and you had to do something on the array, whatever you have to do in the subarray, just think about doing it on the array, and then try to think that you are being given an array and you have to do something on all the prefixes, and then move on to the original problem where you have to do everything on all the subarrays. We will go in this way. Hi, how was your maths before starting coding? Please tell honestly. In my case, I think it was decent before coding. At least till the 10th class, I never relied on the formulas being told to us uh, by the teachers in school. I always tried to just visualize on my own. So I think it was decent. There are 21 people now, so I think we can start. It has been 1-7 already. So guys, should we start? Whoever is active right now, just please tell me in the chat. Okay, only one guy. Let's start. Hello, Shubham. So, this is the first problem of the contest. Find the sequence of strings appeared in the screen. So, we have been told, just 1 second, let me zoom in. Yep. So, the problem says that we have been given given a string target, and Alice is going to type the string target on her computer using a special keyboard that has only two keys. The key 1 appends a character A to the end of the string, and the string 2 changes the last character to the next character in the English alphabet. So, for example, if you have C, it will become equal to D, and if you had something like Z, then it will become A. So, it is cyclic as well. And initially, the string is empty. So, the first key that Alice will push is definitely going to be 1. And we have to return a list of all strings that appear on the screen as Alice types target in the order as they appear using the minimum key presses. So let's understand it with an example. If you had been given the string ABC as the target, Alice will have some target. Let's say it is ABC. So Alice will have a string, let's say str, which is initially empty. After that, Alice has two type of keys. Keyword which will just append A. The key one just will just append A to the string, and the key two that will increment the last character. Okay. Increment the last character. So it is like if the last character was A, then it will become equal to B. If it was B, it will become equal to C, and so on till Z. It will become equal to A. Take. So Alice has to uh, type the string target by using these two keys only. है ना? So first of all, since Alice will have to type A, currently the string is empty. So obviously the first character, like on the first go, Alice will type the key 1, will click on it. So the string will become equal to A. Then after that, you have matched it with the current character. So obviously Alice will now try to type the next character. So again, she will use the key 1. So the string will become equal to A. Then this character A should actually be B. It is not matching. So now Alice will have to type the key 2. Like she will have to click on the type key 2. So it will become AB now. Since it has also matched, now Alice will try to type this character. For that, we I think have figured out what we have to do. First of all, use the key 1 to append a character A. Then you will have to increment it as long as it is not equal to the character which you want there. So you will increment it, and then you will increment it again, and as soon as it matches, now you will move on to the next key. Since you don't have any more characters, so it means that you have achieved the target string, right? So all the characters which you have gone through while typing this target is a ab aba abb and abc, right? A, AA, AB, ABA, ABB, and ABC. It is matching with what we have typed here. Similarly, if you had to type HE, you will initially type A, then you will increment it until it becomes equal to H. Then you will add another character, which will be A initially, and then you will again increment it as long as it is less than E. And as soon as it becomes equal to E, Now you will look if there is any other character. Since there is no other character, the answer is done. I hope the problem makes sense, and the length of the target is very very small, so we can just simulate it. And yeah, we just have to simulate it since we have to tell all these values. So all we have to do is whatever we discussed on how allies will type, we just have to write the exact same logic, that add a character, increment it as soon as it is less than the first character. Once we are done, then add another character, increment it as soon as it is less than b, then increment another character, now increment it as soon as it is less than c, and so on. So guys, does it make sense? Please tell me in chat. Okay. uh, Soham, you can actually just go through the common math topics used for coding. Maybe watch the video of Utkarsh Gupta on YouTube. Utkarsh Gupta has actually made a video of maths for CP in one shot. Just go through this video and it might help you a lot. There's an edge case for the last character Z, so we have to add it so that it becomes continuous. See, the thing is, you have to use the minimum key presses. Now let's say uh, you have to use C, and you are gonna increment it, like you will add a character A, then you will increment it to B, then you will increment it to C, है ना? And whatever character you had to achieve, if you had to achieve the character W, then you will just increment A 24 or 23 times, whatever, to make it equal to W. You will never go in the case that you added a character A, then you increment it as soon as it reached Z, then you again increment it to A, and so on. You won't do it in any of the cases. So we don't have that edge case. They were just clarifying that uh, if you have a Z and you increment it, it can become A. I wanted to build take on this is easy. I just know it's still at this point. Can I develop? Uh, Second year, tier 3. Yeah, you can still do CP even if you just know about STL. You can learn about the other things on the go. So if the logic is clear, we just have to simulate it, and here is the code for that. We are going for each and every character of the target string, and then every time what we are doing is we are first of all incrementing a character A, and then there is this for loop in which, like, I've just written it in a cleaner way, that the last character would initially be equal to A. Sorry, whenever we add a new character, it would initially be A, then B, and so on until it becomes equal to the target character. And when it becomes equal to the target character, you will now go to the next character of the target string, right? So just to simulate it, I have written the second for loop as start from character A and go on till the target character, and I'm again and again just changing the value of the last character of the string to that character ch, and then I'm just pushing it back into the answer vector of strings, that is the answer, and I'm at last returning the answer. So is it clear? Does it make sense? And the reason we are pushing a character here is because I'm gonna be changing the last character. So I wanted a new character whose value I will change again and again. So here it doesn't really matter which character, like what character you push here, because we are gonna change it nevertheless. And the time complexity here should be like this for loop will go on big of target dot size times. So let's say the size of target is n, so it will have big of n time, and this for loop will have at most 26 iterations, है ना, in the worst case. So the time complexity is big of 26 into n, which is not too much. If constraints would be altered, oh yeah, one more thing. At this place we are just pushing back the string into the answer, so this might have a time complexity of as big as big of n, not really big of n in general, because this string, the size of this string would be equal to I plus 1, but in general we can say that the time complexity is 26 into n square. And someone is asking that if constraints are altered, can we optimize it anymore? I don't think so. I don't think we can optimize it any further, since we have to give all of these answer of strings. So we have to generate all of them anyways. Let's move on to the second problem then. The second problem counts substrings with k frequency characters. The problem says that we have been given a string s and an integer k, and we have to return the total number of substrings of s where at least one character appears at least k times. So the problem says that we are being given a string, let's say string s, you know, and we have been given an integer k as well. We have to return the count of substrings such that at least one character in that substring, at least one character in the substring has frequency greater than k or equal to k. Has frequency greater than equal to k. Right. I hope the problem is very straightforward. At least you should be able to understand what we have to do in the problem. Let's take one example. ABACB k equal to 2. ABACB, this is the given string, and k is equal to 2. So the all these strings here would substrings here would be AB, ABA, ABAC, ABACB, and then BBA, BAC, BACB, AACAB, sorry, ACB, and CCB and B. Right, these are the all substrings which we can have in this, and the substrings, this one has a coming up 2 times, this one is also having a come up 2 times, this substring has b coming up more like 2 times, and none of the other strings has, yeah, none of the other substrings have k, the any character having more than or equal to k as the frequency. Okay, so guys, does it make sense? The answer should be here 4, and we just have to do this like the easiest way, the brute force manner can be, there will be n square substrings, just calculate each and every one of them, like find out all these substrings, and then for each and every substring you can just find out the frequencies of all of them, frequencies of all characters. and then there are only 26 alphabets. Check the frequency of all of these 26 alphabets. If any alphabet has the frequency greater than equal to k, then that is the answer. Like the answer for that substring would be 1. Basically you will maintain a variable answer equal to 0, and whenever you find out any substring in which the frequency of any character is greater than equal to k, then just increment answer by 1. I hope it makes sense. This solution will have big O of n cube time complexity, because there are n square substrings, and for each and every substring we are iterating them one by one to find out the frequencies of each and every character. है ना? So big O of n cube will obviously fail. The constraints are small, but they are not very, very small. We are having 3 E3 as the constraints. I think I just submitted. Yep. So here n is as large as 3E3. So something like n cube can't work here, because n cube would be 27E9, which is gonna be very, very large. Like 3 is nothing but 10. 3 to 10 raised to the power 3. So n cube will have 27 into 10 raised to the power 9 operations, which is very, very bad. Something like n square can work, because in n square you will have 9 into 10 raised to the power 6 iterations, and even something like 26n, like since we are having substrings and we have to deal with the frequencies of characters, we might actually end up having uh, a count array, or basically an array for keeping track of frequencies of characters. So we might end up with something like 26 into n square as the number of iterations, which should be around um, 2e8, I think. It should be around 2 into 10 raised to the power 8, which can work because we are not having much of a constant factor other than this. So let's try to optimize this big O of n cube time complexity into big O of n square time complexity, or maybe 26 into n square time complexity. So earlier what we were doing was just a brute force technique, where we had big O of n cube solution in which we were going up for each and every just one second. We had been going for each and every substring, right, one by one, and we were calculating their frequencies from scratch. For all of these substrings we had been finding the frequencies of each and every character from scratch, है ना? And I believe you would have seen this optimization a lot of times by now, that if you look at these two substrings, they're having this part as common in both of them, है ना? So for finding out the frequency of all the characters in this substring, instead of going from scratch, you can just use the like you can just keep track of the frequency this uh, substring had, and just increment this new character to the map or vector, whatever you created for keeping track of frequencies, and you will have the frequency of all of these characters in that way. Does it make sense? This is a very, very common optimization. So if you're seeing this for the very first time, uh, try to spend a lot of time at thinking about it so that it feels very intuitive to you. And please tell me in chat whether it makes sense. Like, does it look intuitive? That why, how we can optimize it by keeping uh, track of the previous frequency and then add this character, so that we don't have to do this redundant part again and again. Can you tell the time complexity of the previous solution, please? I think we did discuss the time complexity for the previous one. Here we had this for loop was having big of n square time complexity. Sorry, big of n iterations, inside which we had n iterations here. When you are pushing back a string into a vector of string, a new string would actually be a copy of that string would be created and being inserted in the vector. So it will have n iterations internally, basically because of n time complexity. And this for loop will run 26 times at max. So the overall time complexity for this for loop would be 26 into n. So the overall time complexity for the outer for loop would be 26 into n square. And the space complexity would also be the same, I think, 26 into n square. Okay, so if nobody has any doubts, then maybe we can discuss this further. So I hope you got the idea that earlier, like in the brute force manner which we discussed here, we had been just finding out all the substrings and then we had been calculating the frequency of all the characters one by one. But here what we will do is, if this was the previous substring which we considered and this is the new substring which we are going to consider, then we won't calculate the frequency from beginning. Instead we will have something like maybe a vector of integers with name frequency, which will already have the frequency of all the characters in the previous substring, and we will just increment this character here. Let's say the character was a, so we will just go and say fric of 0 should be incremented. In this way we will know about the frequency of all characters in this new substring, and we can just iterate over this vector of substrings, sorry, vector of size 26. This frequency array would have size 26 because we have 26 alphabets. So we will iterate over the this vector, and we will see if for any I fric of I is greater than equal to 26 or not, sorry, greater than equal to k or not. Basically, if any character is coming up greater than equal to k times or not, and then we can decide whether we should have the answer variable being incremented or not. If this is true, then answer should be incremented, else it should not be incremented. And there is one more observation you can make for optimizing your solution a little bit extra. That is, if if in this substring there was at least one character having the frequency greater than equal to k, basically answer was incremented here, then for all of the next substrings which contain this substring, basically you're adding one character, all of them would also be good. All of them would also have at least that character having greater than equal to k frequency. So you can do some optimization here, like incrementing answer by the number of substrings you will have in future as well, having this as the prefix, and just add a break statement for optimization. Baki, even if you don't add it, it would still be fine. The code will still run. Okay, so does anybody have any doubt related to this problem or this approach? And by the way, we can even optimize this even further to something like n log n or big O of n by using either binary search with prefix sum arrays or to optimize it to big O of n using sliding window. In both these cases, you will have the 26 factor as well. So it would be n log n into 26 and n into 26 time complexity. But they are not required here because n is pretty small in this case. If n could have been as large as 25, in that case you might have required to use these two things. Okay. If a is greater than I plus 1, then you have to reduce. Okay, you are writing the solution for same comments. Guys, please tell me for this problem, should we move on to the code or do you have any doubts? If you have any doubts, feel free to ask it. Otherwise, we can move on to the next problem. I think it was a bit simpler than what was coming up in the B problem from the previous contest. This B problem could have a follow-up. This B problem could have a follow-up where n would be as large as 25. So I'm giving you guys a to-do that try to solve the problem if n was as large as 25, where you will have to solve the problem either with this way or this way. So try to do it after the contest. It's standard problem, move to code. Yeah, the problem is a bit standard nowadays. Um, so in my code, I'm having just a simple brute force approach, as we discussed here, that we will have okay, maybe one more thing. So for writing the code, you will have two for loops. The first for loop for the starting point from where these substrings will start, and another for loop j which would go further and further, basically in the same way as we find out all the substrings. And as you are going on for each and every substring, you are having a vector of integers count which would be common for all these substrings starting from the same point. And every time we are just incrementing the current character to the count array, and then we are going up across this count array of size 26 to check if there is any character having frequency greater than equal to k or not. And then at the end we are incrementing the answer if found is true. So is it clear? Okay, just one more thing, let me check if okay, nice. Okay, so let's move on to the next problem. The time complexity here is going to be around big O of n square into 26. Now, in general, when n is this huge, this n square into 26 can fail, but generally on Leetcode, it can work because the like the test cases are, I think, not that strict on Leetcode in comparison to code forces. And secondly, we are not having a lot of constant factor, and this is the worst case which we are assuming. In general, we won't have this worst case, or maybe you can have the worst case if k is equal to the length of the string. Yeah, in that case you can have the worst case. Uh, but probably it would be close to the time limit, and if Leetcode is not having very tight constraints, then it would definitely not have any problem. And the optimization I was talking about was here, that if you find out a string, if you ever find out that this is a substring, maybe let's say this is the substring which is having any character having at least greater than equal to k frequency, then all the other substrings which are super substrings for this one, they would also be good. So you can actually just increment the answer by the number of substrings you will see here. So what you could have done was, instead of incrementing the answer by 1, maybe increment the answer by something like n minus j and break. So n minus j or n minus j plus 1, it would be something like that. I know. Okay, yeah, this is working. So it will have even better time complexity, because as soon as you find out the answer, you will just break and you won't go for the next iterations of j. In the worst case, this found will never come, so the optimization will never work. So in the the worst case scenario for this is also the same. Now this is the third problem: minimum division operations to make the array non-decreasing. This says that you have been given an integer array nums, and let me just write it here. We are being given an integer array with name nums, and we are being told about an operation in which we choose an integer I, and we choose an integer I, and we apply the operation. Like, for applying an operation, you will just choose the integer I, and the element on the index I, basically ai, would be divided by, would become equal to ai by the largest proper subset, the largest proper divisor of ai. I think they have used a word as well for this. Mm, let's call this as largest proper divisor, lpd, of ai. And we are being told what is a proper divisor. If you have a number like 6, which is equal to nothing but 2 into 3, 6 has 4 divisors: 1, 2, 3, and 6. So all of the divisors other than 6 itself are gonna be equal, are known as the proper divisors. For any number, all the divisors other than the number itself are known as proper divisors, and the largest of these proper divisors is known as largest proper divisor, or the greatest proper divisor. So 3 is gonna be the greatest proper divisor in this case. We are allowed to perform any number of operations on the nums array, and in this operation what will happen is, we will choose an element, and that element would be divided by its greatest proper divisor, and we have to tell the minimum number of operations required to make the array non-decreasing. We want to make the array non-decreasing here, so it means that for every I, ai should be less than equal to a of I plus 1. And if it is possible to make the array non-decreasing using any, yeah, in case if it is not possible to make the array non-decreasing, in that case we have to return -1. Otherwise we have to return the minimum number of operations in which we can make it in non-decreasing. So is the problem clear? Let me take one example as well. If the given array was 25, 7, then we could have applied the operation on this guy to make it uh, smaller. So 25 is nothing but 5 into 5. The divisors it has is 1, 5, and 25. 25 is not a proper divisor. 5 is the largest proper divisor, so the new array will become 5, 7, which is non-decreasing. So the answer here would be equal to 1, right? And for the next case, 776, here no matter what you choose, for the integer 7, they are nothing but just 7. Basically these are the prime numbers, है ना? These are prime numbers. And for any prime number p, it has only two divisors, that is 1 and the number itself. The number itself is not a proper divisor, so it has only one proper divisor, that is 1. And like, if you apply an operation on a prime number, it would be divided by 1, which does not make any sense because the number will remain the same and you just wasted an operation. So one thing is clear, like the test cases gave us a very big hint, that if you have a prime number, any prime number, you cannot apply an operation in it. Like applying an operation on a prime number does not make any sense. And it means that you cannot make these sevens smaller, and with the operation which we were applying, you are making a number smaller only. No, you can make the number smaller and not larger by applying an operation. So obviously you cannot make this 6 larger in any way, it will only become smaller. So we can say that the answer for this array would be -1. Then we have this case where we are having all the numbers 1. Basically this is already a non-decreasing array, right? So I hope it makes sense that on a prime number we cannot apply an operation. The first observation was that if you have any number ai, applying an operation will only make it smaller. You cannot make it larger by applying an operation in it. The second thing is, if you have a prime number p, it's like it remains to be p. Nothing will happen on it. And there is one more thing. Um, in my case, I already knew about this, that the greatest proper divisor for any number, let's say x, would be its smallest prime number. For any x, its greatest proper divisor would be its smallest prime number, unless the number itself is a prime number. In like this thing is valid even if x is a prime number, because its smallest prime number would be the number itself. Let me show this to you. If you have a number maybe 24, which is 2 cube into 3, then all the proper divisors of that number are gonna be 1, 2, 3, 4, 8, 12. That's it. And 24 is in itself the number 24, so it won't be a proper divisor. You can just say all these numbers has 24 by 24. This is 24 by 12. This is 24 by 8. This is 20. Okay, it had one more prime number, that sorry, one more proper divisor, that is 6. So 4 is nothing but 24 by 6. 8 is nothing but 6 is nothing but 24 by 4. 8 is nothing but 24 by 8. And 12 is nothing but 24 by 2. Sorry, 24 by 3. Yeah, basically you would have seen this in this way now in school. Like we write the number as 1 into 24, 2 into 12, 3 into 8, 4 into 6. So all the divisors of these of the number are these, है ना? So this is gonna be the maximum proper divisor for any number, because you can't choose this largest divisor because it would be the number itself. So its largest proper divisor would be the number at the second place on the right hand side, right? And that number would have been multiplied by something, the smallest divisor, and the smallest divisor other than 1 for any number is the smallest prime number itself. So I hope you people are able to at least accept this as a fact now. This is something In my case, I did notice it while solving a problem on my own. In case if you didn't know about it earlier, now you know about it, and maybe you can try to think of some other facts as well to just make it feel intuitive for you. So for now, even if it is something you were not able to understand on your own, just accept it as a fact now, that for any number, its greatest proper divisor uh, would be, sorry, I think I wrote it wrong here. The greatest proper divisor for any number x will be its x by smallest prime number, not the smallest prime number. Okay, sorry, I wrote it wrong earlier. uh, the fact was, for any number, its greatest common divisor would be x by the smallest prime number, and this is how you can actually visualize it. The greatest proper divisor would be x by the smallest prime number, है ना? So when you change ai, like when you divide ai by its greatest common divisor, greatest proper divisor, then that ai is divided by um, ai by its smallest prime number. Let's call it as sp. So you can cut ai and ai, and you can see that the number will become equal to its smallest prime number. So let's take the example from the this here. For the case like 25, it had transformed into 5, which is the smallest prime number. In case of 6, its prime numbers were 1, 2, and 3. Its proper divisors were 1, 2, and 3. It got transformed into 2. It got divided by 3 and transformed into 2, which was the smallest prime number. And for 7, 7 uh, for 7, the smallest prime number is only 7. So it also got transformed into its smallest prime number. And for 1, this is the only exception here. Oh, wait. Is the internet lost? For 1, it would be transformed into 1 itself. For 1, there is no prime number who can divide it. Actually, 1 does not have a proper divisor either. So I think they should have mentioned something for 1 here, that we cannot apply an operation on a number 1. But you see, you would never apply an operation on 1 anyways, because you can't make the number any smaller. Okay, so now we have got these 3 observations. With these 3, we can actually make some conclusions. The first conclusion is, if you apply an operation on ai, it will become equal to the smallest prime number of ai. This is the first conclusion. And the second conclusion is, if you have a prime number, you cannot change it to anything, it will remain prime. So from both of these, we can actually make a conclusion that on any number, you cannot apply the operation more than once. है ना? For any number, you can apply the operation on it at most once. After applying an operation on it, you cannot apply it anymore. Otherwise, it will be just a waste of operations. Nextly, whatever array we had, we wanted the numbers on the right hand side to be greater and the numbers on the left hand side to be smaller, because we want the array to be non-decreasing. So for every ai, you want it to be smaller than a of I plus 1, right? With this knowledge, can I say that I would like to keep these people normal, and at any place, if I find someone who is greater than the person on the right, in that case, I will apply on operation on this guy to make it smaller, and even after becoming smaller, even after becoming equal to the smallest prime number it has, if it is still larger, uh, it's okay. Okay, fine. I don't know why, but the pen tablets had stopped working. So right now, what I'm saying is, even after applying an operation on this guy, when it got turned into the smallest prime number it could, if it is still larger than the next guy, then I can't really do anything. Can I just give up? Can I just say that, hey, I'm giving up on making the array non-decreasing? Because the number on the left cannot become any smaller, and I could not make the number on the right larger anyways. So I can say that, hey, I'm not able to solve the problem between these two people. So I can just return -1 directly as my answer. And for the other case where uh, I had turned the element smaller and the problem got resolved, if it had become less than equal to the next guy, then I can just move on to the left person and just check again if there is a problem. Like, I can just compare these two people now. So in a nutshell, what we have concluded till now is, whatever elements I have, let's say 7, no, 25, 7, or maybe let's consider 2, 3, 6, and then 7, and maybe not 7, but 63 maybe. No, not 63, 77, and then 9, and then 12. Let's say this is the case, something like this. Then if this is the nums array, and with the observations we had made that you can make the number either smaller or don't do anything, you know. So either you can think about iterating from left to right, and if you can make the number any smaller, then just make it smaller, because if the elements on the left are smaller, then there would be a better chance of uh, having a non-decreasing array. So either you can just iterate from left to right and make the numbers smaller whenever possible. But the problem is, whenever you make the elements smaller, you will use an operation, and you want to use the minimum number of operations. है ना? So you would be a bit confused that, should I apply an operation here or not? And you will have some complications in this case if you try to iterate from left to right, though it can still be solved by using 2 pointers. uh, but an easier approach can be to go from right to left instead, and try to keep the relation between every two elements, that the right guy should be larger and the left guy should be smaller. When you come to this guy, let's say you are iterating from left to right, and you come to this guy, and basically you saw these two people together, the relation was already there. 9 is smaller than 12, so everything is fine. Then you will compare these two people. 77 is greater than 9, so you will have to apply an operation on this guy. Its smallest prime number for 77, like 77 is nothing but 7 into 11. So the smallest prime number is 7. You can turn it into 7. Once you turn 7 into 77 into 7, then your relation will be 7 is less than 9, so it would also be okay. Then you will compare these two people where this is 7 and this is 6. Everything is fine. Compare these two people, everything is fine. Compare these two people, everything is fine. है ना? So I hope you got the idea that you can iterate from right to left and just compare the pairs one by one. If you ever find a case where the left guy is larger than the right guy, maybe like this case, then just apply an operation on the left guy, and even and after applying the operation, just compare it again. If let's say the element here would have been uh, 11 instead of 77, then in that case, even after applying an operation, 11 would have been greater than 9. So you could just say that, hey, I'm not able to solve the problem, I will return -1. So I hope this dry run did help a little bit. Now let me show you the code. So I'm going from the right hand side towards the left, and I have been comparing the two adjacent elements. If the current element is greater than the next element, then I will apply an operation on the current element. I will make it equal to the lowest prime factor of the current number. And if that number is still greater than the next number, then I will return -1. Otherwise, I will go on towards the left again and again. And eventually, I'm just going to return answer. That is the number of times I applied the operation. So I hope it makes sense. Guys, please tell me in chat. Did the explanation help you to understand this problem, or do you have any doubts even now? And if you have any doubts, then feel free to ask. Let me read the chat for now. I think there is some fighting going on in the chat. Um, Yesterday we had a contest in our college. Okay, understood. That's great. So let's move on to the third problem. Talking about the time complexity here. This function for finding out the lowest prime number, prime factor, will work in square root of n. It is pretty much the same as how we find out whether a number is prime or not. This is almost the same logic. And in this for loop, let's consider the worst of the worst cases, that you might have to call this function for every iteration. In that case, the time complexity would be equal to big O of n into square root of n. In the worst case, like, yeah, in the complete worst case. So the time complexity is n square root n, and for the space complexity, it is just big O of 1. For me, I'm able to come up to with a logic, but not able to code in C++ properly on my own. Please suggest how can I improve. It might take some time. Just try to uh, push yourself as much as possible. Like, even when you have coded it up, just remove all the code and try to code it up again, and try to not make the same mistakes which you made earlier. So not only it will improve your speed, you will eventually just make more and more mistakes as much as you practice, and as you improve from those mistakes, you are less likely to make those mistakes. Won't this solution give TLE? No. See, when n is less than equal to 10 raised to the power 5, square root of n would be somewhere around 3 into 10 raised to the power 2. So overall time complexity here should be around 3 into 10 raised to the power 7. And we can have around 10 raised to the power 8 iterations, so it is fine. sorry, we have, oh, sorry. The this n is actually different from the given n. So this is 10 raised to the power 6. So we actually have square root of the maximum element, let's say, or basically 1e6, because all the elements might be as large as 1e6. So the total iterations would be somewhere around 1e8. And just like the last problem, the number of iterations in the worst case is coming out to be 1e8, but we are not having a lot of constant factor. So sometimes even 4e8, like even this many iterations can pass if you're not having any extra constant factor apart from these for loops. So this is most likely gonna be taking around half of the time limit, or maybe even less. And into square root n is 29. No, it's not 1e9 here. It's 1e8 iterations. Oh yeah, Rishabh also wrote this in chat that we had to take the square root of 1e6 and not 1e5. Sorry for the mistake. I just made it right now. Uh, when solving the problem, I had taken 1e6 only, square root of 1e6. Okay, very well. If it is clear, then we can go on to the next problem. This is the fourth problem. Check if DFS strings are palindromes or not. Let me explain the problem statement. The problem statement here is gonna look a bit complicated if you see, but it is not really that complicated. Like the thing which we are doing is not really that complicated. The problem says that we would be given a tree. Let's consider this tree for example, 0 1 2 3 4 5 wala. Node 0 is the parent of node 1 and 2, and node 1 is the parent of node 3 and 4, and node 2 is the parent of node 5, and every node has one character associated with it, that is a a a b b and a. So we are being told that for like there is something known as DFS str, which should be calculated for every DFS, or maybe I will tell you about the problem in a little different way. Let us say the DFS of 0 will return you a string which is gonna be calculated in this way. Uh, the string you get from here, plus this character. That is basically consider. Okay. I'm telling you about the way in which we will calculate the string in a little different way from the problem statement now. I hope you guys know about post-order traversal. Whenever you would have studied about trees, you would have definitely come across these three things: pre-order traversal, in-order traversal, and post-order traversal. These are the three types of depth first searches we use for binary trees. In a normal tree with a root, the in-order traversal might not be there, but pre-order and post-order traversals are still there. So in this case, as we have this tree, having the characters A, B, B, and A. In the post-order traversal, the characters you will get is, first of all, this A, then this B, then this A, then this A, then this B, and then this A. है ना? So the string you will get in the post-order traversal is A B A A B A A B A A B A. है ना? The post order traversal. Okay, so somebody wrote as well. Left, right, root. For binary trees, it is like this. For a normal tree where a node can have any number of children, it might have 10 children, it might have 0 children. It is like just go through all the children first, and then the root. And that's what the problem statement says, that we will iterate over all the children in the increasing order of their numbers, and then we will call the DFS of them. Basically, we will call the DFS function for all the children first, and then we will add the correct character to the DFS string. Fine. So we have to do this. And let us say that this string, which we were getting when we were applying our post or the traversal from the root node, the nodes here are 0, 1, 2, 3, 4, and 5. Let us call this thing as DFS of 0. So DFS of 1 in this case is going to be the post order traversal from the node 1, that is A, B, and this A. So the post order traversal for 1 would be ABA. Then for the node 3, node 4, and node 5, these are the root nodes. So for them, the post order traversal will just contain that node itself. And for the node 2, its post order traversal will have A and then B. So DFS of 2 will be AB. For DFS of 3, 4, and 5, they will just contain A, B, and A. So in a nutshell, what we have to do is, in this way, we can calculate the DFS strings. Like these are the DFS strings for every node. Now for that, like in this way, we will just calculate the DFS strings, and then if this DFS string is palindrome, then answer of 0 should be equal to true, else it should be equal to false. Basically, in the answer of 0, like we will have to return a vector of boolean of size n, where answer of I will tell you, in answer of I, you will tell whether DFS of I, the DFS string for DFS of I, is palindrome or not. That is something you will have to tell in answer of I. So let us take one example. In this example, you have for DFS of 0, the resultant string is ABA, which is a palindrome. So answer of 0 is true. For answer of 1, DFS of 1 gave us ABA, which is a palindrome. So answer of 1 is also true. For DFS of 2, you got AB only, है ना? A and B. So we have a false here. Then for 3, 4, and 5, we got A, B, and A, which are all palindromes. So you got true, true, true. Similarly, for the second example, when you do DFS of 0, you will get A, B, C, B, A. For this example, where they had A, B, C, B, and this is A. So in post order traversal, you will first of all have this string completed, then this node completed, then this node completed, then this node completed, and then the correct node. So this is A, B, C, B, A, which is a palindrome. So it is true for the DFS of 0, and for all these others, there's just one character string, so they are true for them as well. So just tell me yes or no whether the problem statement is clear of what we have to do in the problem. I'm not talking about the solution. Yeah, maybe tell about the brute force solution as well. In the brute force solution, what we can do is, for each I, we can just run a DFS, a post ordered traversal, and calculate the DFS string, and then we can check whether this is palindrome or not. So we will be able to do it in big O of n square time complexity. In chat, just tell me yes or no whether you are with me till this point or not, where we are able to solve the problem in n square time complexity. Hello, am I audible? Okay, guys, sorry for the inconvenience. Actually, light chali gayi. Now I don't have any light source, so I'm turning off my camera as well. And uh, let's try to complete the stream. Okay, so just say yes or no in chat whether you are with me right now or not. And is my voice coming good? Raghav, are you giving CF contest today? Let's see. I'm not sure. How many of you have solved the fourth problem? Whether we can learn these tricks like Fourier pass. This is not a trick of whether 48 iterations can pass or not. This is something I just told from my experience, that I have seen that even 48 iterations can pass sometimes, especially when it is difficult to come up with a test case which will actually have the worst case time complexity. Generally, the lead code test cases are not that good. It's okay. Complete fast code versus contest is there. Oh, okay, 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 okay. So let me just complete it ASAP. Okay, so the thing is, if we have been able to think till this point that for any node you can just run a DFS and find out the DFS string, and then you can check whether it is a palindrome or not, you are going up on the correct path. The only trick, the only tricky part in the problem was to realize that DFS of u is nothing but DFS of child 1 plus DFS of child 2 plus DFS of child 3, and so on till like DFS of child, whatever the number of children are, plus the current character. Let's call this as S of u. And now, if this is the thing, let's say I calculated DFS of 0 and I got something like ABA, ABA. Then, for finding out the DFS of 1, like for calculating the DFS of 1, I don't really need to iterate over the tree once again. Because if I had observed this, like this is a property of pre-order traversal and post-order traversal. In post-order traversal, you are first of all going to all children and then to the current node. So if you were picking up one character from all of them, DFS of 1 would be nothing but some portion, some prefix here. Then DFS of 2, the second child, In case of this example, it had only two children. So for the first children, its DFS will actually give ABA. है ना? The left subtree was having three people. So DFS of the first child will give you this ABA. The next child had two people. So it will give you the next two characters, AB. And then the current character A. Right? Because this DFS of 0 was nothing but DFS of 1 plus DFS of 2 plus A. So in the brute force way, we were calculating DFS of 0 with the help of these two. And then when we wanted to find out the DFS string of node 1, we were again running a DFS of 1 traversal and it will call its children again. But uh, we can actually make some optimization by noting that DFS of 1 would be nothing but this part, है ना? We had actually calculated it, and for DFS of 0, so we can just avoid calculating it again. And similarly for DFS of 2, it is nothing but this part. Now it gives us a good idea that for like whenever you calculate DFS of 0 and you get some big string, है ना? So let's say DFS of 0 had the node 0 had three children, 1, 2 and 3. So what you can do is you can just keep track of the number of nodes in the first child subtree, the number of nodes in the second child subtree, the number of nodes in the third child subtree, and then obviously we'll have the current character. With this, you can just easily find out the starting point and the ending point uh, in this substring, in this string, which is the DFS of 1. Then for DFS of 2, you can just easily find it out. Uh, Basically, there can be multiple ways in which you are able to find out from which s- index till which index is DFS of 1, and then from which index till which index is DFS 2, and so on. Or you can simply use Euler tool here. If you know about Euler tool, then it is going to be a very simple problem for you to solve. In Euler tool, we use T in and T out. We use these two vector of integers, and these two will just keep track of the indices um, in this main string, and then we can use string hashing or manager string hashing, or we can use manager for checking if for checking whether this part is a palindrome or not, whether this is a palindrome or not. We can do it very efficiently by using manager algorithm or string hashing. In my case, I used manager. uh, so if you know about Euler tool and one of these, then in that case the problem is very easy to solve, and I would recommend you to just stop the explanation at this point and solve the problem on your own. But for the other people who don't know about Euler tool and any of these, uh, obviously I won't explain these. These are very standard. I will just show you where to find them. But for Euler tool, I'm gonna just show you the dry run. So uh, let's start. Let me take one example. Let's take this example itself. You have the tree 1, 2, 3, and the characters are A, B, B, A. So in the Euler tool, what will happen is, uh, let me represent T in with blue color and T out with green color. And let me represent the actual string. Let me represent the uh, string with red color. So initially we would be at this point, we will go to the left child, है ना? Let's say we are just applying the DFS of 0, which is a post order traversal for now. So we will initially go to the left child. For DFS of 1, we would have, okay, let me dry run that as well. I'm just showing you a dry run for better clarity. uh, we will do only this part of, first of all, using Euler to finding out DFS of 0 and use manager algorithm at the end. So you would call DFS of 0 by yourself, which will call DFS of 1 now. Now for DFS of 1, you will have two children. So you will call DFS of 3 first, because we have to call them in the increasing order of their numbers. So we will call DFS of 2 here. In DFS of 2, sorry, DFS of 3 here. DFS of 3. Now DFS of 3 does not have, this node 3 does not have any more children. So since it is done with its children, it does not have any. It will just add this character A to the main string, the string str. It would get this character A being incremented. And we are done with DFS of 3. We will go back to uh, this place. Now DFS of 1 will call DFS of 4, the other children it had, the other child it had. DFS of 4 does not have any children, so it will just increment B to the main string, right? B is incremented. Then you're done with these two. You will go back to 1. For 1, both of both of its children are done. So it will now increment its character and go back. Its character was A, and we go back to the we will go back. So we are done with this as well. Now DFS of 0 will call DFS of 2, which will call DFS of 5, that is its child. DFS of 5 does not have, the node 5 does not have any children, so it will call it will have this character A being incremented. Then we will go back to the DFS of 2 function, which does not have any more children to deal with. So it will again go give its character and move on back. So you will have B being incremented, and this is also done. And then the node 0 is also done. So this is how we are doing the post order traversal, and we have been getting the string. Now, during this process itself, while we were going in this way, we will just keep track of uh, the character which was coming up in the DFS of 1, similarly for DFS of 2, and till which point we will just store those informations in T in and T out. These T in and T out are just representing the time in and time out. So for that, one thing you can do is you can just have a variable with name time or being increment, being starting from 0 and being incremented. Or the other thing you can do is just use the information of this string array, this string. Uh, yeah, let me show that. When we went to this node and then we went to this node, the length of the string was 0 at that point, hai na? So for both of these nodes, or actually for all these three nodes, we will give them the t in value as 0. That at the time when we had reached there, at the time when we reach to these nodes, the string does not have any character. It didn't have any character. So whatever comes up in the DFS of these nodes will start from this character. So we gave it 0. Now when you are returning back, at that point you are gonna add a character, है ना? So that character would be added to this um, index 0. So for t of out, we will give it character 0. We will give it the value 0. Then we went to this node. है ना? We went to the DFS of 4. So for DFS of 4, this character has already been placed. Now the character which it will place is gonna be at the index 1. So DFS of 4 will have t in value as 1, and since it is placing its character at 1 as well, so it is out is also having the character 1. For DFS of 1, it has placed 2 characters, and now these characters have been placed. Now the character which it will place a is gonna come at the 3rd place, right? Or basically the index 2. So its t out value, basically the end value, the end of the string value would be equal to 2. And in this way we will give t in and t out value to everyone. So for the node 2, 3 characters would have already been placed while coming to this place. So its t in value would have been 3, and it will go to this place. When you come to the DFS of 5, even at that point, only 3 characters were being placed. So t in is also 3 for this guy. It will place its character on the 3rd index. So t out is 4. Sorry, t out is also 3 because it is placed on index 3. Basically, this 3 comma 3 is telling you that DFS of 5 is nothing but uh, the substring from index 3 to index 3 in the main string str. And then for DFS of 2, at the time of going back, 4 people have been placed. It will place its character on the 5th place. Index 4. It will place its character on the index 4, that is the 5th position. So its t out will be 4. And then for the last guy, its character would have been placed on the index 5. So it's 0 to 5. Basically, whatever we have discussed right now is nothing but Euler tour. Since we don't have a lot of time, I just straight away showed you the dry run of Euler tour. I've not really discussed about all the intuitions behind Euler tour. If you want to study about it, you can just search about it on internet and you can explore CP algorithms. Like go to that website and learn about it. So now with these t in and t out, you can actually find out the DFS strings for any of these nodes. So for DFS of 2, you were actually getting AB, right? Now let's see if you're getting the same thing here as well. It is from index 3 to index 4. 0, 1, 2, 3, 4. Index 3 to index 4 is nothing but AB. Similarly for DFS of 1, it is from 0 to 2. ABA, right? Similarly for any of the leaf nodes, that is A or B or this A, you can just verify it yourself as well. So this was just a dry run of Euler tour. Again, I am giving you a disclaimer. If you have not studied about Euler tour, I would recommend you to leave the problem and go and study about it first. There is no point of solving a problem with a technique which you don't really know yourself. Um, so first study about it, and then once we have got this string, which is nothing but the post order traversal, and we have got this tn and t out array as well. Now all we have to do is we just have to say like answer I will be true if in this str substring from t in of I to t out of I of str is palindrome. Does it make sense? This substring of str from t in to t out is nothing but the DFS of I, है ना? And earlier we had already seen that answer of I would be true if the DFS of I is a palindrome. So now we can say that we have been given a string and we have been given some starting and ending points for every I, and we just have to tell whether from T in to T out, is this a palindrome? Or you can relate it with a problem where you have been given a string and you have been given n queries. In every query, you will have some starting point and some ending point, and you have to tell a substring from the starting point till the ending point. Is this a palindrome or not? Is this a palindrome or not? You just have to tell this. So this is now a standard problem where, like, you can either solve it using string hashing. If you don't know about string hashing, you can search about it on uh, search about it on CP algorithms, or you can use manager's algorithm, which is I have used. I believe it is more optimized, and it is specifically for this type of problems where you have to check some substring of the main string to be a palindrome or not. If you don't know manager's algorithm, because I also don't know about it, you can do something like this. Go to your browser. Oh, wait, what is this? Go to your browser and just search managers algo. ठीक है? And then you will get a CP algorithms link at the top. Sorry, internet is going a bit slow, especially because right now I am streaming on mobile data. And okay, this has opened. So if you want, you can study about it. The main purpose of manager's algorithm to solve the problems like the current one only. And you can do something like what I did. I just copy paste this code and use it for my purpose. So I just have created a template in which I'm having a function with name manager. I just created this function with the help of these functions which were written here. And I have created a function with name as palindrome. So you can do the same. Yeah, you can do this exact same thing where you will copy paste this code, and whenever you want to see whether there is a string which is palindrome or not, for pass that string into a manager function, a function with name manager, you will get some vector of integers, and whenever you want to see whether substring of that function is palindrome, pass on the start and end pointers and that vector of integers. I know you won't understand this I'm doing by just a glimpse of peek at it during the session. If you want to learn about it, you can learn about it after the session. Or if you are like me, I don't want to your time at this thing, just copy paste the code and use it the way I'm doing. So I've done the natural logic. I created a string str. I created an HSC list first and into arrays. Then I apply the DFS function. In the DFS function, I have finding out in TLE, which is like Euler tour, and I have been uh, adding the character of the current Hi guys, am I audible? Hello, hello. Okay, I think I'm audible. The Wi-Fi is down, so I'm having some bad internet connection right now. The Wi-Fi is down. Okay. Unfortunately, the stream had stopped at some point, and I didn't get to know about it. So I think the time when I was discussing about the manager's algorithm, it got down. So let me start on from that point itself, or maybe let me recap the whole problem from the beginning now. And yeah, just for the confirmation, uh, if the voice is coming good right now or not, please say yes or no in the chat. And I have a couple of minutes only before my battery goes dead. So what we had discussed was we could use DFS of I, like we could run the DFS function from each and every node to get some DFS string, and then we can check whether it is palindrome or not and get our answer. But it was very inefficient. It was having a big of n square time complexity. So we did move on to some other way. We had realized that DP of 0 would be nothing but DFS of the child 1 plus DFS of the child 2 and so on. And then it will have its own character. है ना? And so on. So we could just calculate DFS of 0, which is the root. And for every node, we can just find out the T in and T out values with the help of Euler tool to find out uh, the starting and the ending point of the DFS in the string. So basically, if DFS of 0 is giving you ABA, ABA, and the T in and T out values for the node, uh, yeah, we had discussed it here itself, that if T in and T out values for node 1 is coming up as 0 and 2, so the DFS of 1 would be nothing but this substring from index 0 to index 2, that is 0 ABA. है ना? You can just find out the uh, DFS of 2, DFS of 3, and so on very easily. And now the problem became that you have been given us a string, and you will have n queries. In every query you will be given some starting and ending point, and you will have to tell whether the substring from this starting point till this ending point is a substring or is a palindrome or not. For that, either you can use the string hashing algorithm, or you can use manager algorithm. In my case, I did use manager's algorithm. So I had a template of manager's algorithm which helped me to find out whether a substring is palindrome or not. In my case, I already had a template of mine. If you don't have one, either you can use my template or you can create your own template. In my template, what I do is, first of all, I pass on the string in which I want to use a lot of queries. By the way, in manager's algorithm, uh, the string should remain static, so you should not make any updates in the string. If you are using string hashing, then you can make updates as well. In manager's algorithm, we will pass on a string which should remain static. It Manager's algorithm will do something and will at the end return you a vector of integers. After that, when you have been given this vector of integers, in this vector of integers, if you want to see whether the string from L to R is palindrome or not, you can check it in this way. So I believe that I might someday forget about this condition or this expression. So that is why I always prefer to just keep a function with the name is palindrome inside which I will just pass on the starting point, ending point, and the vector which I had got from the manager function. And by calling this, I can find out whether a string is a palindrome or not. Now, this is something related to my template. You might consider having some different ways of uh, for checking whether a substring is a palindrome or not. It's up to you. So I hope this session did help you a bit. And sorry for the inconvenience caused due to the bad internet right now. I have been streaming on the mobile data network because uh, uh, like the Wi-Fi is down right now. So thank you. And talking about the time complexity part, this DFS function will take big O of n time. So we are spending big O of n time here, and this will also take big O of n time, and this will also take big O of n time. So overall time complexity here should be big O of n, and the space complexity should also be equal to big O of n. And that's it. So thank you for watching, and bye bye.